Hey class, what we're going to do today is chromatography. Now chromatography is how you separate different contents from each other. Okay? And to do this I'm going to try and use a Sharpie, an Expo, and a highlighter. And the pen probably won't work, but I'll maybe try it. Alright, and what you need to do is you get these 4 pieces of paper, and these are chromatography paper, and you draw a line across the bottom with pencil. And the reason you use pencil is that the pencil doesn't actually form any chemical bonds with the paper. It's sheets of graphite that sit on top of the paper. So it's going to look kind of like this. And then you're just going to take your marker and you're going to put a dot on that spot. Okay? So the first one's Sharpie. I'll actually probably write on the top here, Sharp. And then the next one's going to be the Expo marker, so I'll write Expo. And then the blue highlighter, I'm not going to label because it should be just really obvious, and the pen should also be obvious. But the other 2 are black and might not work so well. So what I've got here is I've got 4 pieces of paper, okay? And I have here a solution of water, and here is going to be 70% ethanol. That is alcohol, and that's what I'm going to put here at the bottom of the jar. And what's going to happen is as I put the paper in the jar, the liquid is going to come up on the paper. So there's going to be the pen, and I'm going to put... Now you'll notice the liquid is below the ink line. And that is intentional, because if you don't put the liquid below the ink line, what ends up happening is the ink just dissolves in the liquid. You know, if you put a shirt into the washing machine, the only thing that happens is the washing machine causes the liquid to dissolve into the liquid. And that's probably just happened there. You can see how the water splashed up, and then the Expo is now going down into the water. It should go up with the ink as it moves, okay? But I don't want it to go up too much. All right, so that's the Sharpie, highlighter, pen. And then we're going to watch as these move. I'll put just a little bit more liquid in here so this works a little better. And I'm going to explain how this works on the board. All right, so I've got my Expo. I'll use this board pen. So paper is lots of glucose molecules that have been stuck together with an oxygen in between them. Okay? So this is really hard to draw through. And so on the end of each glucose, there are alcohol groups, so an oxygen and a hydrogen. And this is not quite a perfect showing of cellulose, but it is. So what happens is these bonds keep going, and this forms cellulose. Now, cellulose, another name for it here, is fiber. So when you eat food, the stuff you don't digest is basically this. Right? It's sometimes a little bit different. And we can't break the bond between the glucose molecules. So what we have to do is have bacteria that can do it, or it helps to slow down the processing of our own food, and it's really good to have fiber in your diet. Okay? So what happens is water, which is H2O. All right, so we're going to have an oxygen, and then a hydrogen, and ethanol, which was the other thing that's over there. So that's carbon, and it also has an OH group. Okay? So the dyes that are present in pens are going to have various attractions because of things called intermolecular forces to the substance involved in the chromatography. So there's the paper, and that's what the marker sticks to and chemically bonds to. And then, as the water moves up through the paper, so it's going here, so we got our sheet of chromatography paper, and we got the line where the pencil is. As the water goes up the paper, eventually it reaches this ink spot. And then the water keeps going. Now the question here is whether the ink is more attracted to the paper or to the solvent, the water, moving through it. And when we get to the end, this is called the solvent front. And what happens is ink moves with the solvent depending on how attracted it is. If it moves completely with, then it has as much attraction to the water as it can be without being attracted to the paper. So there's a number called an RF, okay? And that's the retention factor. And if the ink moves with the paper, so let's say this distance here is 2.00 centimeters, okay? If the ink moves with the paper, then the ink moved 2.00 centimeters, and the paper moved, or the water moved 2.00 centimeters, and so the RF equals 1. Now let's say our ink stops here, the main body of it. You pick a spot that looks like it has the most dye, and that's your mean distance traveled. And this, let's say this is 1 centimeter, okay? Now your RF is going to equal 1 centimeter divided by 2 centimeters, and that's going to equal 0.5. And what you're measuring with your RF is the various attractive of the chemical components compared to the paper. So, and compared to the solvent. So when these inks separate out, we can find out what kind of intermolecular forces they have. This is actually very similar to any other kind of diagnostic tool where you're trying to find out what something is. There's a technology called gas chromatography, which is this, but it's in gas form. There's liquid chromatography that goes through big tubes. Instead of a piece of paper, they got a giant tube. It's called liquid chromatography. When they check your DNA, they can move your genetic material across an agar plate with electricity. Oh man, sorry guys, it's Friday afternoon right now. And it just, depending on the attractiveness of the various chemicals and their intermolecular forces, shows what they have and various components. I'm going to go back over here. We can see that the water for the ink has moved up to about here. So what I would do is I would take this out. I'd go draw a line across here. And then you take a ruler and measure this, and this will be about 5 centimeters. Then you go to the middle spot here. This is going to be 2.5, so it's about 0.5, which is pretty cool. Now this one, that has an RF of 0, because it didn't move at all. So the Sharpie has no attractiveness at all to water, and I probably should have known that was going to happen. Whereas over here, it looks as though the highlighter has 100% attractiveness to the ethanol, and the expo marker is actually somewhat attracted too. That'd be about 0.75. Okay. Sharpie, I don't know if they even would dissolve in the ethanol. There's a chance. It looks like it does. So that's the basics of chromatography. And make sure you use pencils, because what's going to happen in 5 minutes with this? What's up? Oh, this is my pen. Oh my goodness. This was the highlighter. Sorry. This was actually my Pentel G2, and it apparently does combine with the paper and has really high retention factor with ethanol. So what's going to happen in a few minutes here is the water is going to dry. But if you have your mark there and your mark there, and then you sometimes would circle here if you think the color is going to disappear, and then you can measure your RF value with a ruler from there to there divided by that distance over that distance. Okay, if you have any questions, please send me an email. I hope you enjoyed this small mini lecture on chromatography.